Hello and welcome to Investment Insight. Before we begin, make sure to subscribe and hit the like button. Now let's break down what's happening in the markets today in a clear and simple way.
Sounds good.
So right now, the smartest minds in Silicon Valley are basically burning billions of dollars to build a digital god.
Yeah, that is exactly what it feels like.
Right. They are locked in this massive race to build a supercomputer brain capable of absolute peak performance, just assuming that whoever builds the smartest AI inevitably controls the future.
Which is the standard narrative.
Exactly.
Yeah.
But based on a huge shift in recent data, we are looking at data spanning from late 2025 through March 2026. The winner of the global AI race might not be the one who builds the smartest model at all.
Not even close, really.
Yeah, the real war, it turns out, is about who can build a brain that is just, good enough and get it into the hands of 8 billion people for pennies.
And that right there is the crux of the disruption we are looking at in today's deep dive. Because the narrative we constantly see in the mainstream, it focuses almost exclusively on raw benchmark performance.
Right, like which AI scored higher on the bar exam or whatever.
Exactly. Or which one solved a harder math problem. But underneath that surface level arms race, low-cost, open-source AI models originating from China have moved entirely out of the fringe.
They aren't just toys anymore.
No, they are no longer just budget alternatives for hobbyists. They've
Yeah.
actually become the baseline infrastructure that the global market is using to build real scalable companies.
And there is a specific number from a March 23rd report by the U.S.-China Economic and Security Review Commission that, it completely upends the traditional Silicon Valley narrative.
Oh, the Hugging Face data?
Yeah, exactly. So if you look at Hugging Face, which, just for the beginner trying to make sense of this, it's essentially the central clearinghouse, or like an app store, where software developers go to download AI models.
That's a great way to put it, yeah.
So on this app store, 7 of the top 10 most downloaded models in late 2025 were Chinese,
7 out of 10.
which is wild. Alibaba's Quinn ecosystem alone has spawned over 100,000 derivative models.
And to add to that momentum, recent Reuters data shows DeepSeek's R1 model briefly overtook ChatGPT as the most downloaded app in the U.S. App Store.
Right, really. The U.S. App Store.
Yeah, the U.S. App Store. And the Quinn family has also surpassed Meta's Llama in cumulative downloads. So we are looking at a scenario where an estimated 80% of U.S. AI startups are currently building their products on top of Chinese open source models.
80% of American startups.
Hey.
For a listener trying to understand why a developer in, say, Austin or San Francisco would choose a foreign model over something built domestically by a tech giant, it really just comes down to incredibly simple economics, right?
Always does. It's a cost.
Yeah, because the data shows these models are 10 to 20 times cheaper per token than the major U.S. alternatives.
Right, and we should probably define token real quick.
Good call. So a token is basically the fundamental unit of data and AI processes. Just think of it as a single word or like a piece of a word.
Yeah, it's the currency of AI computing.
Exactly. So when you are paying 10 to 20 times less for every single word the AI reads or generates, that changes the entire mathematical foundation of running a startup.
It changes everything. You can actually afford to fail a few times.
Right. Let me put this in a way that makes sense for anyone who drives. Not everyone needs a high-performance Ferrari just to go to the grocery store.
Most people definitely don't.
Right. Most people just need a reliable, affordable Honda Civic. And these models, they are the Honda Civics of AI.
That is the perfect analogy.
But I gotta say, I have a hard time believing price is the only factor here. Like, a cheap car that breaks down every mile is totally useless to a business owner.
Yeah.
So are these models actually robust enough to run a scalable enterprise? Or is this just, a race to the bottom on price?
Well, the truth is, they are highly capable. But the underlying strategy isn't just about selling a cheap standalone product. It relies on this mechanism called the adoption iteration loop.
The adoption iteration loop. Okay, break that down for us.
Sure. When an AI lab open sources its code and the underlying waits at rock bottom prices, they are essentially crowdsourcing their research and development to the entire world.
Okay, but how does that actually work in practice?
Like
if Alibaba gives away the code for nearly nothing, how does that benefit them? It kind of sounds like corporate charity.
it does, but think about those 100,000 derivative models you mentioned earlier.
Right.
So a developer in the US downloads the base Kuhn model. They tweak it specifically to, say, read dense legal contracts, or maybe to analyze medical imaging for a local hospital.
Okay.
In doing so, they figure out the model's blind spots, they fix them, and they often push those improvements or those highly specific data sets right back into the broader open source ecosystem.
Ah, I see.
Yeah, the central lab absorbs all of that decentralized innovation. The sheer volume of developers tinkering with the model creates this massive feedback loop.
So the more people use it in highly diverse scenarios, the faster the model improves.
Exactly. It's a calculated strategy to win dominant market share by flooding the zone, rather than obsessing over achieving the absolute highest score on a standardized AI test in some isolated, multi-billion-dollar laboratory.
I see the logic there.
Yeah.
You flood the zone, you get the software developers hooked because the barrier to entry is basically zero.
Yep.
But, and here's my skepticism, developers don't pay the big bills. Everyday consumers and traditional businesses do.
That is a very fair point.
Right, because building a model and getting other coders to play with it is really only step one. How do you bridge that gap to actually monetize? Getting a local bakery or like a non-tech corporate office to use an AI model requires a totally different approach than convincing a software engineer to test out some code.
It absolutely does. And that transition from pure R&D to commercial application, that's the second phase of this shift. We are moving from analyzing the cost of the models to analyzing the engineering of the distribution pipelines.
Distribution pipelines.
Yeah.
So getting it into the hands of the end user.
Exactly. It does not matter how brilliant the AI is if average people have to go out of their way to find it, sign up for a separate service, and learn a totally new interface.
That makes sense.
The strategy relies on aggressively integrating the models directly into the digital platforms people already use every single day.
Right, and the data highlights a major move by Tencent on this front. According to recent analysis, they recently took an AI agent based on the OpenClaw architecture, named it Clawbot, and integrated it directly into WeChat.
Which is massive.
Huge. And for listeners unfamiliar, WeChat isn't just a basic messaging app. It is essentially the operating system for daily life in China.
Yeah, you use it for literally everything.
Exactly. People use it to pay for groceries, hail cabs, book doctor appointments, message their boss. When you drop an AI agent into that environment, you aren't just getting users to play with a novelty chatbot.
No, you are integrating AI into the mundane transactional fabric of over 1 billion lives instantly.
1 billion lives. That's incredible scale.
And we are seeing parallel moves aimed squarely at the enterprise sector, too. Like Alibaba launched a platform called Ashio Work alongside this coordination tool called Wukong.
Wukong, what does that do?
It's specifically designed to manage multiple different AI agents simultaneously for a single business. So it's handling logistics, customer service, and inventory all at once.
Oh, wow.
And to your point about how they intend to monetize, pulling this off required a fundamental shift in corporate structure. On March 16th, Alibaba actually reorganized its entire AI business into what it now calls the Alibaba Token Hub.
The Alibaba Token Hub.
Yeah, with CEO Eddie Wu taking direct hands-on control.
You know, the phrase Token Hub is incredibly revealing. They aren't positioning AI as a prestigious, high-end software suite anymore. They're treating it like a utility company selling electricity.
That is the perfect way to look at it.
They just want to be the grid that everyone else plugs their appliances into. But, and here is the catch, if you are treating it like a utility and giving the base product away for next to nothing to capture that market share, you are burning an immense amount of cash.
Oh, absolutely burning cash.
Right. Meanwhile, the big U.S. companies are hyper-focused on building the smartest possible brain and charging a premium for access to it. Isn't there a risk that the utility approach just ends up commoditizing the technology to the point where no one actually makes any money?
Well, that is a legitimate risk that investors are actively weighing right now, but you have to look at the historical precedent of network effects.
Okay, how so?
The new playbook is straightforward. Release a model that is good enough, link it to massive distribution channels like WeChat or enterprise software, and drive up daily usage to astronomical levels.
To get the data.
Exactly. Massive usage generates a staggering amount of data. That behavioral and transactional data is then fed back to improve the model, making it more intuitive and deeply embedded.
So it's a loop.
Right. The business model has shifted from selling a boxed software product to managing a token distribution network. And historically speaking, superior distribution and overwhelming network effects almost always defeat raw, isolated technical performance.
It's just a constant spinning flywheel. You get the volume, you get the data, you achieve market dominance. But let's pivot and look at what this actually means for the physical economy.
Yeah, this is where it gets really serious.
Because the research indicates this strategy creates two distinct feedback loops. We have just covered the digital loop, the software developers and the messaging apps. But the second loop is the physical loop.
The physical loop, yes.
And for an American listener right now, especially under the current Trump administration, where maintaining U.S. manufacturing independence and technological supremacy is a massive central policy priority, this physical loop seems like the real high-stakes battleground.
It really is. The physical loop is where the geopolitical and economic stakes escalate dramatically. The industry refers to this as embodied AI.
Meaning artificial intelligence that actually has a physical presence.
Exactly. We are talking about factory robots, autonomous delivery drones, assembly line sensors machines operating dynamically in the real world.
So let's break down how that actually works for the listener.
Sure. Imagine an AI-powered robotic arm on an assembly line. Its task is picking up delicate glass screens for smartphones.
Okay.
At first, it might drop a few or apply too much pressure and crack them. In a traditional closed-loop software system, that robot just fails and requires manual reprogramming by an engineer.
Right, someone has to go in and fix the code.
Exactly. But with an embodied AI connected to a massive open-source network, every single microfailure, every calculation regarding grip pressure, angle, spatial physics, it's all recorded.
And sent back.
Yes. That data is transmitted back to the central model. The model learns exactly how much torque is required, updates its understanding of real-world physics, and instantly pushes that improvement out to every other robot on the network.
Wow. So it is essentially crowdsourcing physical intelligence at a global scale.
You got it. And a closed lab in Silicon Valley simply cannot replicate that sheer volume of real-world physical interaction.
So the threat here is that by having the cheapest, most widely distributed software model, China creates the default global standard for these physical machines simply through sheer volume.
That's the core of the issue.
It totally reminds me of the classic VHS versus Betamax war in the 1980s.
Oh, that's a classic example.
Right. Betamax had better video quality. Technically, it was the superior product.
Yep.
But VHS was cheaper. It licensed its technology to multiple manufacturers. It flooded the consumer market, and it became the undisputed global standard.
Yep.
Or even looking at mobile operating systems with Android versus iOS. Android is on billions of cheaper phones globally, which dictates app development standards everywhere.
The standardization factor is crucial because in the current AI landscape, competition is no longer strictly about writing the best code. It is about controlling academic networks, setting hardware standards, and dictating platform access.
We actually saw a stark example of network power recently, right?
We did. On March 27th, the major AI academic conference, NeurIPS, initially expanded restrictions on research papers coming from sanctioned Chinese institutions.
Okay.
However, they quickly retracted those restrictions after facing a massive boycott threat from the global research community.
That is wild. The network is already strong enough to force the hand of major institutional bodies. That is a massive shift in power dynamics.
That's a huge shift.
Let's ground this for the listener, though, regarding U.S. policy. Under the current Trump administration, there is a heavy focus on bringing manufacturing back to the United States. We're seeing tariffs, trade negotiations, and all these incentives to build factories domestically. But if an American company builds a brand new, state-of-the-art factory in Ohio, and the most cost-effective, capable robots they can buy are running on a Chinese open-source AI framework, what does that actually mean? Like, how does this specific push into embodied AI challenge the U.S. economy?
Well, the strategic harm occurs at the foundational level of the next industrial revolution. Because does the physical location of the factory even matter if the digital brain controlling it is tied to a foreign ecosystem?
Right, if the data is all flowing outward anyway.
Exactly. The concern isn't just about a smarter chatbot drafting your emails. The concern is that the standard operating system for global manufacturing, logistics, and robotics might be built entirely on a Chinese software framework.
Which gives them all the data.
Yes. Data is the gravity of the AI industry. It pulls everything toward it. If their models achieve the most usage globally, they accumulate the most real-world industrial data. Over time, that compounding advantage could severely shake long-term U.S. dominance in technology and manufacturing.
So relying solely on a strategy of isolated innovation and peak performance isn't enough.
Not anymore. The U.S. desperately needs a robust strategy for distribution and bundling to counter this.
Okay, I see the strategic threat clearly. The VHS strategy applied to global robotics and supply chains, but I have to push back on the logistics of actually pulling this off.
Okay, go ahead.
We know the master plan, but running these models at that scale, powering billions of smartphone queries and millions of factory robots simultaneously, it requires an unbelievable amount of computing power. Do these companies actually have the physical hardware to support a billion people using AI every single day?
That is the multi-billion-dollar question. Hardware is the ultimate bottleneck. But according to a March 27th Reuters report, Huawei has developed a new AI chip, the 950PR.
The 950PR.
Right. And this chip has successfully passed rigorous testing by major players like ByteDance and Alibaba. Huawei is reportedly planning to ship 750,000 units this year alone.
750,000 units is mass production. I mean, that is not some small pilot program.
Not at all.
But there is an important technical distinction we need to make here. Based on the data, this chip is optimized for inference rather than training. Let's clarify that for the listener, because tech jargon can really obscure what is actually happening.
Yeah, it's a vital distinction.
So think of training an AI like sending a human to medical school. It takes years, it was incredibly expensive, and it requires massive computational horsepower.
Right.
And those are the super high-end chips that the U.S. government heavily restricts from export to China. But inference, that is when that fully trained doctor actually goes into a neighborhood clinic and diagnoses a patient with a cold in the real world.
Exactly.
It takes much less brain power to diagnose the sniffles than it did to learn all of human anatomy in the first place.
That is exactly right. And that distinction highlights a critical geopolitical workaround. For the past few years, U.S. trade policy has been heavily focused on choking off the supply of the ultra-powerful training chips to China.
Because the logic was,
Right.
if they can't train the massive models, they can't win the race.
Exactly. But because inference requires significantly less raw compute power, optimizing for it allows these companies to bypass the reliance on the heavily restricted top-tier U.S. chips from companies like NVIDIA.
Wow.
They are essentially saying, our medical school might be slightly slower to build, but once the doctor is trained, we have all the cheap stethoscopes we need to run 1 billion clinics globally.
And the Huawei chip is designed precisely for that clinic, to run millions of daily queries from everyday users highly efficiently.
Precisely.
Okay, so the hardware bottleneck is being addressed through optimization. But this brings me back to my earlier skepticism. The reality check on profitability.
The money problem.
Right, because giving away top-tier AI models at rock-bottom prices while simultaneously manufacturing hundreds of thousands of chips to support them,
Right.
that requires astronomical capital expenditure.
It's incredibly expensive.
It reminds me of how Uber operated in its early days. Remember that? They heavily subsidized the cost of every single ride you took, basically bleeding money on every transaction, just to run traditional taxi companies out of business and get everyone hooked on their app.
Oh, absolutely.
Is this the exact same playbook? Like, are these AI companies just setting billions of dollars on fire to buy market share, or is there an actual viable path to not going bankrupt?
Well, the market is intensely debating that exact tension right now. Chinese AI firms are facing mounting pressure from their own investors to demonstrate actual sustainable profitability.
Because market share doesn't pay the electric bill.
Exactly. Market share does not automatically translate to profit. And an aggressive open source strategy is brutal on a balance sheet. The margins are razor thin, and the infrastructure costs are massive.
And there is a fascinating irony in the data regarding who is actually profiting from this dynamic right now.
The U.S. companies.
Yeah. U.S. companies are taking full advantage of this massive cash burn. For instance, the U.S.-based coding assistant Cursor is utilizing these incredibly cheap open-source Chinese models to power their own back-end products.
Which is so smart.
It really is. By keeping their operational costs virtually at zero, they are boosting their own massive enterprise valuations in the U.S. They are essentially surfing the wave of subsidized Chinese AI to enrich themselves.
It is a brilliant arbitrage play by U.S. developers. Furthermore, this aggressive distribution strategy is creating internal friction. It is not just U.S. policymakers raising red flags. Chinese authorities themselves are reportedly raising internal security concerns regarding the rapid, unregulated spread of autonomous agents like OpenClaw.
So they are moving too fast for their own regulators.
Yes. When you prioritize breakneck speed and maximum distribution above all else, control and safety inevitably take a backseat.
Wow. So putting all these pieces together, the Honda Civic models, the integration into billion-user apps like WeChat, the physical robots gathering factory data, and the massive hardware pivot toward inference chips.
What does this actually mean for you, the listener, trying to navigate this market? Whether you are an investor or just someone trying to understand the economy, where is the actual value going to settle?
For anyone looking at the economic reality of AI, the focus has to shift away from the developers of the foundation models.
Okay.
If you are investing in or building a business solely around creating a base model, you are participating in a brutal race to the bottom on pricing. The real sustainable value lies in the token distribution networks.
The toll roads, essentially.
Yes,
Oh.
the cloud providers hosting the models, the enterprise software platforms that successfully integrate the AI into daily corporate workflows, and the hardware companies manufacturing the inference chips.
The stethoscopes for the clinic doctors.
Exactly. The entities that control the daily digital infrastructure and the physical deployment are where the actual cash flow will be generated.
That is fascinating. So to wrap up this deep dive for you, the listener, the fundamental rules of the AI war have changed entirely right under our noses. It has shifted from an academic race to build the smartest, most complex model in a laboratory to a gritty commercial race to build the cheapest, most widely distributed utility. The Honda Civic approach is rapidly capturing global market share.
It really is.
And as this software pushes out of our phones and into physical robots, into embodied AI, the battle over who controls the standard operating system of the global economy is in full swing.
Which leaves us with a broader consequence to consider. If these inexpensive, ubiquitous models become the default global infrastructure, we are not just looking at a massive shift in economic wealth.
What else are we looking at?
We might be looking at a future where the global standards for AI safety, algorithmic censorship, and data privacy are no longer debated and decided by politicians in Washington or executives in Silicon Valley. They will simply be dictated by whoever manufactures the cheapest, most widely adopted robot brain. So who will be the real billionaires of the next decade? The ones generating the electricity or the clever entrepreneurs building the everyday appliances that plug into it?
Don't forget to subscribe and hit that like button.